Welcome back for number 6. You can see the problem that has been identified, or the figure that's been identified for use with number 6. And first I'm going to start by marking it up. Okay, AD equals BD, and EA equals EB. Alright, so then they ask me, what can you conclude about ADB and EAB, or AEB? Alright, so I'm going to sketch these, and again, it's not going, I can already tell you, it's not going to be a great drawing, so it doesn't have to be. It just needs to be able to communicate the information for you that makes sense. Alright, so here are the two triangles they're talking about in this problem. Alright, so ADB, and marking it up again, so we can see what it was. It was this, and this, and this, and this. And you probably didn't need to do that to see this one, because it's pretty straightforward. But it does help sometimes to get them separated. What can you conclude about triangle ADB and triangle AEB? Well, they are isosceles. This is what we're looking for there. They have each a pair of equal sides. Okay, and then they ask, what can you conclude about triangle DBE and triangle DAE? Alright, now I probably don't really need to sketch this again, but let's sketch what we've got here. Alright, so here's A, D, oops, D, E, this is E, this is B, and that's D. Alright, so what can you conclude about them? We have this marked like this. You can see we have two sides, and this is the same side as this. You can see that more easily in this figure. The same side. So by reflexive property, DE equals ED. So that means that these are congruent, these triangles are, by SSS. Right? So you could say triangle DBE is congruent to triangle DAE. And they didn't ask me why, but it's SSS. Why is angle BED equal to angle AED? Okay, so now we just did a triangle congruence statement, and you usually know what follows after that. Angle BED, that's right here. Why is it equal to AED? That's right here. Okay, and I'm going to mark them over in my original figure too. They're equal by, we just did triangle congruence, those are corresponding angles in those two triangles. So by CP equal, corresponding parts of congruent triangles are equal. Why is triangle BEC congruent to triangle AEC? Okay, so let's take a look and see what we've got here now. Alright, so triangle BEC. Alright, now I'm starting to running out of sketch room here, so I'm just going to put it over here. Alright, so there's E, B, and C. And over here, we've got A, C, and E. Alright, and we're marking our parts here. You can see AE, EB. I'm just reproducing the marks that I've got on the original. Okay, so you can see what you've got here. You've got congruent triangles by SAS. Side, angle, that's the included angle, side, side, angle, side. So they are congruent by SAS. Alright, and then so Y is BCE now. let's see what we got. BCE, why is that equal to ACE? Okay, so we're talking about this angle and this angle. Why are they equal? Well, we just showed those triangles that they're contained in. Here we're talking about these two. Why are they equal? Because of corresponding parts of congruent triangles. So once again, CPCT equal. Alright, so why is DE perpendicular to AB? Now this one is a little trickier. So what parts are we talking about here? We're talking about DE, that's this one, and AB. Okay, so, well, here's this angle. They are a linear pair. They share one side. Their other sides are opposite rays. All right, so that means that, and they're both equal. We know that from the previous question by CPCT equal. So this is called Theorem 8, and it comes up from time to time, but not as often as a lot of the other theorems. So if the angles, and you can look back and check this theorem out if you want, if the angles in a linear pair are equal, whoop. Sorry about that little excursion. The angles in a linear pair are equal, then their sides are perpendicular. And that is called Theorem 8. And it makes sense, doesn't it? If you have a linear pair and they're equal, then there's only one measurement they could have, right? If I have two angles that are equal, so x plus x equals 180, the only measurement they can have is 90 degrees. And what do 90-degree angles form? They form perpendicular lines. So that's a little bit of a justification for that. Okay, there you have it. Number 6. See you down the road for number 7 or 8.